Hello and welcome everyone. I'm Jim Olson, Executive Director for the National Tile Contractors Association. I want to thank you for taking time out of your day today to attend today's webinar titled TCNA and ANSI, Specifying Successful Tile and Stone Systems by the Book. This program is sponsored and presented by MAPEI. Before I introduce today's speaker, I am reminding you that during the webinar you will be muted. Please use the questions area on your computer to type in your questions. We will answer all of your questions at the end of this presentation. If the audio on your computer is poor, call the number on the invite to this webinar to listen on your phone. All of our webinars are available to watch at any time on the NTCA YouTube channel. They will be loaded shortly after this webinar. Within 72 hours or 3 working days, they will be on there. So please go to the NTCA YouTube channel and you'll be able to watch all of our videos, including all technical webinars. This will give you easier access to watch all current and past programs, hoping to make it really convenient for you. All right, here we go. Today's speaker, Jim Whitfield, is the Director of Technical Services at MAPEI. He is actively involved in the development of tile industry standards on TCNA, ANSI, and ISO committees. Jim is an NTCA ambassador and a proud member of the NTCA Technical Committee. He's the current president of the MMSA, Material Methods and Standards Association. In addition, the Construction Specification Institute, CSI, honored Jim with a fellowship in 2001. And I want to thank Jim personally. He is a friend of mine and he is really a great supporter of our industry and what we do. Thank you, Jim. Welcome.
Thank you, Jim. What a nice introduction. I appreciate that. So today I'm going to spend some time going over the TCNA and ANSI handbook, not page by page by any means, but how you use it, how you can find things in it. There was a good conversation on one of the forums on Facebook regarding this, and somebody had shared one of my previous presentations of this this webinar, and I mentioned that I'm doing it again today. I think I try to do this at least once a year because I think it's essential that contractors and design professionals really know how to use the TCNA and ANSI handbook. I think it's a great tool. I think that there are, easy ways to manipulate or move around in it that many probably aren't aware of. So let me kind of take you through some of that and maybe hopefully give you a new perspective and see how you can use the TCNA and ANSI handbook. And this is an AIA presentation, so if you would like continuing education credits, please in the question thing, put in your AIA number, name, etc., and we can get those to you an email address. This presentation will explore the review of the industry standards and resources like the TCNA and ANSI handbook, understand the coordination between the two of them, understand tile setting materials and application methods, and learn how standards are changed, frequency, and why these changes can benefit your project. How to use the TCNA to improve the quality of your product present specifications and project in general. I like to start off with a very basic understanding of these materials because I'm sure I'll repeat most of them a couple times throughout this webinar. So what you see here is actual grout joint, an adhesive to adhere the tile to the wall. In this case, a mortar bed is the substrate for the floor. Waterproof membranes below that, on top of a pre-pitch or pre-slope mud bed, and then typically you'd have a plywood or concrete substrate. So this concrete substrate, we've got the pre-slope towards the drain, waterproof membrane going towards the drain, and then the mortar bed on top of that is just to provide a good stable substrate to adhere the tile to. All right, there you go. Sorry, I got locked up because of that pen. Tile systems, we're going to talk about thin set mortar. Typically one of the most common mortars out there is typically applied from 3/30 seconds to 1/4 of an inch thickness after it's been beat in. So this is a standard, could be modified, non-modified, or improved mortar, but applied in a thin set manner using a gauge trowel so that we get a nice consistent bedding of that material. Large and heavy tile mortar just recently got into the ANSI handbook, formerly known as medium bed mortar. It goes down a little bit thicker, not always, but can. It's now recognized by ANSI with an H designation. So if you see a mortar like 118.4H or 118.15H, that means that's a medium bed or large and heavy tile mortar. Improved LHT it can be troweled thicker than other materials. They can go as thin as 3/30 seconds, the same thin application as regular thin set, or as thick as 1/2 inch after it's been beat in. This is really to compensate for large format tiles, heavy tiles, ones that want to sag or slump. So the LHT mortar, again, gets the designation of H. We'll talk about mortar designations again in this presentation, but so you might see 118.1, 118.4, 118.15 mortars with the H after them, and that would be a large and heavy tile mortar. Mud bed or thick set, typically 1 1/4 inch thick, wire reinforced or not, bonded or not, would be applied to a wall or floor. Let me talk real briefly about the ISO standards because it's a setup for some of the changes that we've made in ANSI. So in the international standard organization has its own documents for tile and setting materials and so on. And I honestly, it's 13007. I think they've done a great job of being able to explain the products very simply and should be easily recognizable in packaging, etc. So let me talk briefly about that. When it comes to thin set mortars or cementitious type mortars, you would get a C designation. C1 would be a typical normal mortar. C2 would be improved, so typically a polymer modified or something like that. So, and then you also can have different designations at the end of it. So if it's a fast setting mortar, you would get an F. If it was a non-slip or slip resistant type mortar, a T. Extended open time, an E. These next two are two that we don't currently have in the ANSI handbook, but S1 is for deformable or flexible type mortars. S2 is for highly deformable or highly flexible mortars. P1, plywood adhesion, and P2, improved plywood adhesion. So you could have a cementitious mortar, C1, say C2, S2, so improved, very premium cementitious mortar that has good flexibility or allows for deformation. There's also dispersion materials, adhesives, like mastics. You have a D1 or a D2 for improved. And then some of the characteristics or designations for that is accelerated drying, A slip resistant, same as for cementitious mortars, is a T. And E is for an extended open time. One thing I should mention about these designations is that they can be used, you can get multiple ones. So for instance, let's say I want to pick out a mortar that has good open time and can be applied pretty non-sag because I'm putting a gauge porcelain tile on a wall. So I might look for a C2, T, S2. So I've got with an E. So I've got extended open time, non-slip characteristics, and it allows for some deflection. And then there's R for reaction resin, epoxies as well as urethanes, an R1 or an R2 for improved, and then T for slip resistance. Grouts are similar. We've got CG for cementitious grouts, CG1 is for normal and CG2 is for improved. And some of those characteristics are fast setting, which would be an F, high abrasion resistance, so pretty tough grout is an A, and reduced water absorption is W. For reaction resin grouts or epoxy type grouts, we've just got the high performance characteristics. They're higher than improved cementitious grouts. So those are RG. And you'll see them on packaging, and you'll see them in literature commonly. I know we've got them all throughout our literature and packaging, because at the time it really made a lot of sense. It was the easier way to understand the characteristics of that mortar. So now we'll talk about TCNA, or the Tile Council of America Handbook. It's a handbook for ceramic tile installation. It also includes glass tile, mosaics, and hopefully soon gauge porcelain tile. But ANSI as well. There's a variety of ANSI standards that we use in our industry, and we'll get into that in a little bit more depth once we get into the ANSI later in the presentation. The simplest way for me to explain the TCNA and ANSI handbook is they do work together. The TCNA methods reference ANSI standards. So they really kind of, I like to think of the TCNA handbook kind of as the drawing or plans on a project, right? And ANSI as the specifications. So they establish the quality of the tile and the materials that are going in. So if I say I want a 118.7 grout as opposed to a 118.6, it's an improved grout, high performance grout. And so that establishes the quality of it. So think of it, like I said, a set of plans and spec book that you're using on your project. TCNA is the plans or the drawings, and ANSI is the spec book. Both TCNA and ANSI are voluntary standards. TCNA is really just a guidebook. It's not really a standard per se. There's no compliance requirements, not like you would have with the building code, where the code might call out for the amount of deflections allowed on the floor. That's not the case in the case of TCNA and ANSI. However, they are heavily followed by the courts. So if you were to have a problem on a project, if you were to have a failure, and maybe they brought a consultant in, or for that matter, you just get into a dispute, possibly with the setting material company or whoever, more than likely, TCNA and ANSI are going to be brought into the court with you. They are considered to be our best practices, our industry standards in the United States. So they do carry a lot of weight, even though it's voluntary. The development of TCNA, ANSI, and ISO standards is really through what we call industry consensus, or open committees. This is kind of like what it looks like when you go into a standards meeting. And that's not really true. But you can imagine trying to get an ANSI standard approved as an example. There's 65 people on that committee. So it's a lot of work to try and get a brand new standard added to the handbook, or to the standards book, to get an agreement with everybody in the room. It's really quite a chore, but there's nothing more rewarding than the industry standards committees, in my opinion, because we're actually able to influence the future of our industry. It's very, very enriching. And TCNA handbook meets about every 2 years. They have rules similar to ANSI, again being open consensus, and they're published annually for now well over 50 years. Somebody's making noise out there. Can you see if you might have your mic open? And if so, just mute it. It's the little green button up above. Just click it. 2011 made some major renovations to TCNA handbook when they combined glass, tile, as well as stone into one industry resource. And changes can occur now on a yearly basis due to digital voting. In other words, we don't have to sit in a room and raise our hand anymore. We can actually do it by email and voting electronically. In 2020, some of the changes, well, before I get into the changes in 2020, one question I'm commonly getting, and we typically do this time of the year, is when the 2021 will be out. And to be honest with you, I don't know for sure. Typically, TCNA really went to publish it and make sure that the new handbook was out by coverings, which would typically be in spring of this year. But now we've moved that back due to COVID. And so I still would expect the 2021 handbook to be out in the spring of 2021. But so right now we still have the 2020, which is what we're working out of. And some of the changes that occurred in 2020 were revised shading and variation in the natural stone tile selection installation guide. And that was really about lofting stone. You know, if you have, I'll say 20 cartons of Carrara marble, or for that matter, any kind of a stone, you really should open up and take pieces from those 20 different boxes and make sure that it gets mixed up well, so that you don't have block type patterns that occur because of just differences within the stone. You know, one thing about stone is it's not as controlled. It's controlled by Mother Nature, not exactly coming out of a machine where you can punch out a specific color. So sometimes you have heavier veining, or gold is more pronounced in one, where black line might be more pronounced in another. And so it does really make sense to try and open up the boxes and mix them well, maybe even lay them out on an area so that you can see the changes. Within the handbook, as I said, it really gets into this in more specifics and recommends that the superintendent or the owner of the project approve of the lofting or the mixing up of the boxes. Again, just trying to avoid a real block pattern where you can see changes within the die lots, if you might. There's some more things on tile layout considerations, joint sizes, layouts, and patterns, and that really gets into grout joint spacers and how they can kind of set things up square if you might, but that doesn't mean it's going to square up your room. You still need to take time and make sure your layout is good, and the spacers will be another tool or an accessory, not really the proper thing to make your layout correct. And the advanced certification for tile installers, the ACT program, to the qualifications within the installer and contractor qualification guide, they added the gauge porcelain tile program. That wasn't available for a while, and that was only added, say 2019, 2020. So that was added to the qualifications language. All right, understandable. The TCNA handbook is 1.5 inches wide and weighs quite a bit. It's not something that I like taking to meetings when we're going to industry trade associations. I've got mine electronically, and I have a hard copy as well. Both are marked up well, trust me. But it is a good sized book. And the fact that we added stone to half of it, it does seem a little intimidating. I can totally get where installers are coming from when they pick up this large book and they're like, how does this benefit me? So let's talk about some of the things and how the handbook's put together, and maybe we can help clear up some questions for you. The most directly applicable portions of the handbook are the methods themselves, or the drawings with the content. The methods are numbered so you can make an easy reference to them. All of the method numbers start with either an F for floor, a W for walls, B or SR for bathtubs or showers, or steam rooms for that matter, C's for ceilings or countertops, or P for pools and water features. There are some other initials as well, but those are the main ones. After that comes a method number and the year. So obviously when we get this handbook out in the spring of 2021, it'll say, for instance, F113A-221, like you see on the drawing on the right. The A is something I didn't talk about, and that only comes up on occasion. And in this case, it denotes installation that would be above ground as opposed to at grade. So that one is called out. There is an F113-17 or -21 and F113A-21. A, again, above ground. Some of the resources within the front of the handbook, there's a lot of documents in the front end, again, adding to weight and confusion sometimes. There's the product selection guides, which are very, very helpful. How to know the differences between the different types of membranes. Could be stone, could be mosaics or glass. A variety of different things are written up in there. Membranes, thin sets, all that. Field and installation requirements. Very, very good guide. Quick read, so please take a look at it if you haven't in the past. A floor tiling installation guide, environmental exposure classifications. We'll get into some of these in a little bit more detail, like environmental exposure classifications. Ceramic and glass tile installation methods, natural stone tile installation methods, the TCNA tile initiative. And EJ 171 or the movement joint guidelines for ceramic tile, glass, and stone. In the back of the book is, in my opinion, some of the most important or best resources within the handbook. It again has a write-up on ISO and the ISO standards, which you'll see within the methods as well. Each of the installation methods have an estimated weight for that method, how much that type of system adds weight to a floor, a mortar bed versus thin set, quite a bit. Test methods are referenced, so ANSI and ASTM type test methods are referenced in the back. But really, honestly, one of the most important tools, in my opinion, is the method locator by application. So if you want to know what a method, how it's put together, and for instance, a steam room, or for that matter, it could be a floor, interior, exterior, different substrates from plywood to concrete, etc. Just look it up in the method applicator section in the back, and I'll show you a little bit more on that. As I said, the installation guides are methods by type. So ceramic tile, porcelain, and glass tiles are on the front of the book. Natural stone and dimensional stone tiles follow that. Methods for application areas are floors, interior or exterior. F113 is just an example. Walls, interior or exterior. W211, again, is just an example. Ceilings and soffits, again, starts with a C, and there would typically be a -21, C315-21 for next year's 2021 TCNA handbook. Bathtubs, showers, and receptors start with a B. Countertops, C. Swimming pools with a P. RH for radiant heated floors. TR for tile renovation or renovations. Steam rooms, refrigerator rooms, fountains, SR. And movement joints, EJ for expansion joint. 171 is the method. This is what a typical handbook looks like. I'm trying to grab an arrow again. So I'm just kind of breaking down a standard. You would have a CAD detail in the upper left-hand corner, in almost all cases. This is F113. This one was actually in 2017. Recommended uses. This is for slab on grade construction where no bending stresses occur and thin bed installation of tile is desired. So it's not for a slab above grade where you've got anticipated deflection or a lot of movement. Service rating, we'll get into this in more detail as well, but it's for extra heavy. So it can go pretty much anywhere. Environmental exposure classifications, we'll come back to that, but very, very important. Typical weight of the system, again, as I said, this is a thin set application with tile, about 5 pounds per square foot. It includes the weight of the substrate, materials, adhesives, and so on. The limitations of this method, membrane options, the requirements. So the concrete has to be well cured, dimensionally stable, free of cracks, waxy or oily films, and curing compounds, so we can bond direct to it. Materials, this is where we call out ANSI standards as well as ISO. Preparation by other trades. We aren't always preparing our own substrate, concrete being a good example. We walk on a project, typically the concrete's already there. It's not something we have to pour ourselves. So that's preparation by other trades. Movement joints, again, EJ 171 is a reference to that. Installation specifications, again, the references to ANSI, installation standards. Notes, and these notes could be anything that might be relevant to this type of method and really helpful. So if you're going through a method, take a minute to read the notes. I think you can find them to be quite helpful. If you're, for instance, looking at this method for radiant heat slab, this tells you that you can go to RH 110, and a similar method is there for in slab radiant hydronic heat. And materials for sustainability or green design. Let's talk a little bit about service ratings. Remember I showed you in the previous one that the service rating was extra heavy. So based on a test called ASTM C627, the Robinson floor machine, the TCNA handbook gives you different areas of use. So we'll get into this in a little bit more detail in future slides as well. But these service ratings are kind of to give you an idea of where that installation might go. If you're, for instance, trying to put a quarry tile floor on in a commercial kitchen and anticipated heavy car traffic through it, as an example. That could be for moving materials in and out of the cooler, could be for moving materials into the dining area, or anything like that. This would be a great reference tool. Let's look at that a little bit more. First, let me talk about the Robinson floor tester. The Robinson floor tester was designed by Robinson at Clemson University back in the early 70s or before that. It's considered the most common way of measuring a floor assembly or floor system in the tile industry anyway. And recently, I'll say 2 to 3 years ago, I was involved with a committee that did an update to that standard. On the left, you see the traditional Robinson machine. And generally, it's either suspended from above or it has a yoke going through it, a center point through the slab that allows this to turn. And then this is one that we had in our one of our warehouses, a Robinson without the protective cage on it that is required. But we extended it in order to be able to do gauge porcelain tile on wood joists and see what kind of effect it would have on the tile as an example as we added different weights and so on. That's not a common setup, by the way. The Robinson basically rotates around, and service ratings are from residential to extra heavy. So with different cycles, we add different weights. And they rotate anywhere from 450 times per rotation, and then we'll add typically 3 cycles of that and then add some additional weights. So if it only went 3 cycles, it would be considered a residential type performance. And let me give you an example of how we put these floor assemblies together. It's a 4-foot by 4-foot, 4-inch concrete slab. On top of that, we may put thin set, 118.4 mortar and porcelain tile on top of that with grout joints filled with cementitious grout. I put that into the Robinson assembly and let that thing go. And it rotates and rotates and rotates till it's close to 1,500 cycles, 15,000 cycles, and all the way up to 14 rotations or 14 cycles up to extra heavy. And that would be typical rating for that type of material. For porcelain tile direct on concrete, you would anticipate that going all the way till all the testing is done and it's surviving that testing very, very well. As opposed to if I had a gauge porcelain tile and I had a minimum of 4 grout joints in it, and I installed that over, let's say I put it over a peel and stick rubbery membrane that's used for crack isolation. I would not anticipate that going all that far, maybe light commercial or residential for that matter. And the reason for that is because it's spongy, and as we add different weight and continue to go through those rotations, eventually gauge porcelain tile, being whether it's a 1/4 inch or an 1/8 of an inch thick, 3 millimeters, or 5.6 or 6 millimeters, it's a lot on a tile. Traditional tile is about 10 millimeters, by the way. So you can see it could break down a grout joint, it could break down a tile, and once that happens, then you stop the testing. And so that's where service ratings come from, and they can be really a very, very good tool. Environmental exposure classifications. So this originally started out as a way of classifying backer boards. And once the committee kind of realized what they had here, they realized that really it made more sense to be used to say where a TCNA method can be used. Anywhere from residential dry areas, your powder room for that matter, to residential wet, and that could be a shower. High humidity, heavy moisture, residential would be like a steam room. Residential exteriors, obvious. Residential submerged Could be anything from a water feature to a pool or a hot tub for that matter. The same thing's true of commercial. So you got C1, C2, C3, and you'll see a method that says it can go C1, C2, C3, but it can't go any further than that. Or for that matter, it may say C1, C2, C3, C4, C5, C6, and can't go submerged. But that's a way of calling out a method where it can be best performed. Really a helpful tool. Movement joints. Like them or not, they're needed and really a necessary tool. So those have also gone through some changes over the years. Previous to 2011, we had the interior recommendations that there be a soft joint all the way through the tile, through the mortar, to the substrate, either filled with a profile or a proper sealant and a backer rod. There would be 24 by 36 in each direction, 24 foot by 36 foot in each direction. So if you had a very, very large room, you would anticipate having a soft joint at least every 24 feet or possibly up to every 36 feet. 2011, that was changed to 20 to 25 feet interior. And the reasoning behind that was that they laid out better compared to what the concrete industry actually typically put in. Exterior recommendations were from 12 to 16 feet. So there should be a soft joint every 12 feet or every 16 feet at a bare minimum. And that got changed in 2011 to every 8 to 12 feet. One thing I can't stress enough about movement joints is they're essential. Tile is as small and as dry as it'll ever be when it comes out of the kiln. And from that point on, as it takes on moisture, it can actually expand a little bit. And that's why you see floors peaking like you see in this lower right-hand picture. In areas interior, when you've got excessive moisture or direct sunlight, like large skylights, you can also get more expansion or thermal expansion contraction, or in this case, moisture expansion contraction. So again, instead of the interior recommendations of 20 to 25 feet set up in 2011, the recommendation is every 8 to 12 feet. And I'll also say with glass tile, the most expansive tile we have, they should always be on the low end. In other words, what I mean by that, if you're putting glass tile into an area that was very, very moist or had direct sunlight, you should have movement joints every 8 feet, not 12, not the max, the very minimum, every 8 feet, and perimeters and protrusions to the floor. Above ground slabs also have the recommendation for interior, that interior areas follow the exterior recommendation of every 8 to 12 feet. But it does stress in the method, EJ 171, that because of limitless conditions and structural systems on which tile can be installed, the architect or designer shall show specific locations and details of the movement joints on the project drawings. That's an important step. Tile contractors are not really structural engineers. They don't know where all the movement's occurring. So it makes more sense for a design professional to be used to provide that. So about 2017, we made a change and said interior recommendations should just say maximum every 25 feet. We don't have to say the minimum. And the exterior recommendations or interior moist and direct sunlight areas still remained 8 to 12 feet. In 2020, same thing, still the same. So movement joints are essential. Either you place them or Mother Nature will, but they're going to relieve their stress somehow. And I'm sure you commonly walk into a restaurant and look at the floor and you see a crack going right down the middle of a bunch of tiles in a straight row, where they probably covered a movement joint in the concrete slab, and that's cracked through the tile. Well, that's not necessary. Let's talk a little bit about ANSI. It's typically revised every 5 years. Again, because of digital voting, we can make changes on the fly now and make minor changes year to year. But it is referred to in the TCNA handbook, as I pointed out in that one method, F113-17. It includes specifications, environmental conditions where the materials should be used, and coverage, how much contact of the adhesive should you have, or mortar, between the tile and the substrate. That's important. Different types of ANSI standards, A108, like A108.6, are installation standards, or a new standard that was created last year, A108.20 is the new standard for gauge porcelain tile installation for exteriors. So A108 are installation standards. A118 and A136 are material standards. Those material standards say how a tile should be made or what the tolerances are for a tile, as an example. A137.1, the specification for ceramic tile. A137.2, the specification for glass tile. A137.3, the standard for gauge porcelain tiles and gauge porcelain tile panel/slabs. Why does it say panels/slabs? Because that is consensus, folks. This is exactly what I'm talking about, is an industry consensus committee. When they were creating the material standard for gauge porcelain tile, some of the people wanted the large ones, larger than 1 meter by 1 meter, to be called panels. And some were adamant about being called slabs. So the standard now reads specifications for gauge porcelain tiles and gauge porcelain tile panels/slabs. Call it what you'd like. And A137.1 is for sustainable ceramic tile, glass tiles, and installation materials. A green guide, if you might. All right, I mentioned it already, but I'll get into this in a little bit more detail. Important changes to the gauge porcelain tile ANSI standards. And this is a new book that you see on the right. It is available today at the TCNA website. It has the A137.3 standard in it for the materials section for gauge porcelain tile. It has the ANSI A108.19 interior installation standard for gauge porcelain tiles, panels/slabs by the thin set method. And new, as of last year, 2020, the ANSI A108.20 exterior installation of vertical and overhead gauge porcelain tile. So that is a brand new standard, and all three of these are in this handbook that you see on the right, and it's available at the TCNA website today. Just go to the website and look at publications. Back in 2012, there's some additional changes that occurred in the ANSI handbook, really regarding mortars. And we had 118.1 for dry set mortar, non-modified, if you might. 118.4 for modified dry set mortar. At that time, I think it's a polymer, latex polymer modified, but that was removed to just modified. And there's a new standard that was created called 118.15, improved modified dry set mortar. This standard really brought about a whole different type of mortar. With the 118.4 only being there before, they had products that were on the street that were extremely flexible, and some that were barely met the industry standard. So there's such a wide variety of things in 118.4. 118.15 really did a lot of good for our industry. So I'll talk about that, and I'll also talk about mortar designations, because that came about at the same time. Again, if you look at the ANSI standards for materials, 118s, you have 118.1 dry set cement mortar, 118.4 modified dry set cement mortar, 118.11, often forgot about, because 118.11, you have to pass all of the test standards or requirements in 118.4 and additional ones for adhering to plywood to make it a 118.11 EGP mortar, or exterior glue plywood, latex Portland cement mortar. And the new 118.15, improved modified dry set cement mortar. So why at 118.15? High performance mortars really needed their own specification. As I said, the 118.4 kind of became the standard performance mortar, if you might. It's modified, but kind of the base level, if you might. 118.15 is really established for high performance mortars. And I'll show you some of the reasons why that's important, or how it's really made, improved, modified, and what makes it different than the others. It has a much higher shear strength. It also has a new test called heat aging. So in the tile industry, we do a shear test, and that's true of all the shear. All of our bond tests are done through shear. But this one is done with heat aging. Let me explain that test, because I think that'll help explain why 11815 is something you might really look for. So new heat aging. We take 2x2 porcelain tile, bond them together face to face, offset by 1/8 of an inch, right? So we have a thickness of mortar, of, in this case, 11815 mortar, bonding the two porcelain tiles together face to face, offset by 1/8 of an inch. Those specimens are cured for 14 days at 70 to 77 degrees, lab temperatures, followed by 14 days at 158 degrees Fahrenheit. 158 degrees Fahrenheit. So 14 days at room temperature, 14 days at 158 degrees Fahrenheit. I hope that makes sense to you guys, because that's extremely important. And you understand a mortar that might be good for high temperature areas or areas that might experience a lot of thermal shock. This is what you want to be looking at. So the shear bond, even at 158 degrees, after 28 days of curing, 14 days at room temperature, 14 days at 158, must still be better than 400 PSI. That's exceptionally high. So the one value of heat aging is you can't do it just by increasing your cement content in the mortar. You have to do it also by premium quality polymers and things that will allow for the shear test to get that type of strength, as well as deal with these temperatures. It requires a high polymer content and a better quality cement to achieve 11815. Some areas where you might consider a 118.15 mortar, where freeze-thaw is important, like where Jim Olson lives right now, up in Minnesota, where flexibility is desired. Maybe you've got an elevator lobby on the 14th story of a large commercial building, and you know that there's movement in that floor, where improved bond strength is necessary. We want to really have a good strength to the substrate. Where improved shear strength is positive. Where improved thermal existence is needed. Again, going from hot temperatures to quick cool down. I know I lived in Colorado previous to moving to Florida, where I'm at now, and it wouldn't be uncommon for us to get 3-4 inches of snow at night, and then next day it's 50, 55, 58 degrees, and it all melts. And of course, at night, it drops back down closer to freezing. All that water that was on top of that tile and grout and so on is now within the system and is getting wet and freezing. And of course, you know what water does when it gets frozen? It expands. So it really had to have some great thermal resistance, low absorption as well. Good heat resistance is important too. So again, freeze-thaw areas you might consider on decks and balconies. Consider it where large format tiles and there's significant expansion contraction can be expected, maybe due to sunlight, heat, for that matter, a lot of moisture as well. Above ground floors where you can anticipate deflection or movement. This is where also that ISO deformation standard is nice. Hopefully we'll add that to some of our designations sometime in our future. From a test standpoint, this gives you an idea of some of the shear strengths for a 118.1 non-modified mortar. Let me get a little arrow so I can point that out. 118.1, so a basic open time test, tensile bond strength after it's been exposed for 20 minutes is 75 PSI, and that's true for all of the different ones. But when it comes to 28-day heat aging, you can see that there is no testing for that at 118.1. There is no testing for that at 118.4. But again, for wall tile, it has to have better than 450 PSI after 28 days. 14 of those days at 158 degrees. You'll see that all of the shear strengths are improved. We go from 150 for 118.1 to 200 PSI. That's 30% higher for 118.4, and then 250 PSI for 118.15. Let's do that again in porcelain tile, just selecting one shear bond tile to tile after 12 weeks cure is better than 150 PSI, then it goes to 200 PSI, and there is not currently one for 118.15. In the case of freeze-thaw, there is no test for 118.1. There is for 118.4 at 175 PSI. So it has to cycle through freezing and drying for 28 days. And then 250 PSI when it comes to 118.15. So you can see there really is some exceptional strengths differences. Porcelain tile, again, has to be greater than 400 PSI after 28 days, including 14 of those days at 158 degrees. So I think this gives you a bit of an idea how 118.15 is really an improved mortar. I can't move my slides if I have the arrow out. All right, one other thing that we did in 2012, we added mortar designations. So I mentioned it earlier with the large and heavy tile mortar, which was added last year, but we added in 2012 an E for extended open time, an F for fast setting, and T for non-sag, similar to the ISO ones. And just recently added an H for large and heavy tile mortar. So again, if you see a mortar that has 118.4 F, you know that it's a fast setting mortar. It's not uncommon that you can have an ANSI standard that is going to use a combination of these. I was talking before about a gauge porcelain tile being applied to a wall. You would like to have extended open time, right? Because you put mortar on the substrate as well as the tile. You don't want it to skim over too quick. And we'd also like non-sag characteristics so that once we put the tile up there, it's not sliding down the wall. So you can see a 118.4 TE would be how that designation would look. What happened to 118.11? Again, remember what I said earlier, that 118.4, you have to pass all of that first. That's the primary test for 118.11, and then the gauge porcelain tile on top of that. I'm sorry, the plywood on top of that. So how do mortar designations help the tile contractor? Well, if used properly, let's say, for instance, an architect's calling them out, you can get really specific in bidding, right? I mean, you know exactly what your competition is going to be bidding. Maybe a medium bed mortar. If everybody's bidding a medium bed mortar or a large and heavy tile mortar, that certainly makes your bidding a little bit easier. You can easily compare product to product, competitors as an example. You can really get specific in your product selection. You know, you want to get a mortar that will hold up a large and gauge porcelain tile like you see in this picture here. Again, I'm sure you want non-sag characteristics as well as extended open time. Be confident the products are specified are project specific. To an architect, you can get very specific in how you call out your mortars and get the best performance out of your tile system. You can help generate a reference standard based on high performance specification for your specific project. The owner knows in the case of these mortars, they're getting the best performance they can out of their tile system. And they could possibly get a better warranty based on making it project specific. Tell you can with MAPEI. All right, other changes to 118.108 installation standards. I brought this up before and I like to repeat it because it's overlooked frequently. If you have a tile that is not square, you cannot have a 1/16 or an 1/8 of an inch grout joint. It's absolutely impossible. The larger the tile, the more out of square, the larger the grout joint has to be, whether you like it or not. So there are within the industry standards calibrated and rectified porcelain tiles, rectified being machine cut edges, and typically the squarest. If you want to call out for a calibrated tile with rectified joint sizing, you're going to have a mess on your hands. It says within the standard that the actual grout joint shall be at least 3 times the actual variation of the facial dimension of the tiles applied. So if a 18 by 36 rectangular porcelain tile is out of square by 1/16 of an inch, the grout joint should be no less than 3/16. And that means the contractor can make that change just based on the tile that they receive. There also can be a little bit of irregularity in the center line of the joints if you have hand molded or rustic tiles. And under no circumstances should the grout joint be less than 1/16 of an inch. That's within the industry standards. Again, this gives you a little bit of an idea of calibrated versus rectified, the minimums and maximums. You can see the caliber range, and then minimum for the rectified is much tighter. It's actually twice as tight. And the same thing's true of dimensional warpage and warpage diagonal. So much tighter on the rectified, and that's the way it should be. All right, and kind of wrapping up, I really want to stress TCNA handbook's not a specification, it is a reference. So it's intended to be a guideline, but a very, very important one. A quick reference can provide means of simplifying or standardizing installation specifications for any of the tiles, glass, mosaic, or ceramic or stone. In addition to referencing the handbook, architects, specifiers should specify the tile and installation materials using specific locations, movement joints on the drawings. So, you know, in addition to just calling out a TCNA method, you really need to reference ANSI as well. And in addition to that, show the locations for movement joints, what are anticipated. I would strongly suggest that, or at a bare minimum, ask for shop drawings on where they're going to be placed. Use ANSI standards to develop specifications. Specifications are a reference, standards are a reference tool again. Specifications still have to adhere to building code ordinances, trade standards, practices, and climate, depending on where you're located. The industry standards constantly change. They're minor little changes every single year, and sometimes much larger, as you heard about in 2012 when it came to ANSI standards and mortars. So they really could be substantial changes. Don't continue to reference an old book. Keep up on your TCNA and ANSI handbooks. They're essential tools, and there are major changes that can benefit you and your project. Tile can be the least expensive finish you will ever install in a building, or the most expensive. The difference is in the quality of the materials and the installation. Thank you. And I'm open to questions, or and I also leave these websites up here so you can kind of see how to get to TCNA and ANSI, et cetera.
Jim, great job.
Thank you.
I want to thank you for this. I want to thank you and MAPEI. It's great to always have reviews and go through ANSI and TCNA handbook and just get a feel for it. I want to make a comment that comes from all of our trainers. The NTCA trainers are saying that they're in agreement with a Facebook post that you put on about a great way to learn about these publications and how they work is to use them and present a program like this. And they'll agree 100% with you. That is the way to learn.
Agreed. It really is. And it is a good thing. It's a good thing.
So unlike some of our programs, Jim, we don't really have any questions today. I think your explanation and going through it, I think people need to take the time now to pull out their ANSI books, their TCNA handbook and ISO, and just do some research, look at them, continue to learn. I think one of the most important things was the idea at the back of the TCNA handbook on how to look up by a procedure by, how did you say that?
Methods by application?
Methods by application. That's the best thing you said in the whole thing.
It is. I'll tell you what, in my honest opinion, that is an excellent, I'll call it table of contents. And I've actually talked to TCNA about moving that up behind the what are now the table of contents. And we're kind of in agreement on that. So I don't know if that was formalized, but I know we intend to do that sometime in our future, because you want to find a method quick. Go to the back of the book. Trust me, that little guide, few pages back there, are some of the most helpful pages in the book by far.
especially for those that are just learning to use it.
Right,
What a
right.
great way to find out the methods. I think moving it up would be great, and I know our trainers are talking about it. They talk about that table of contents in the back, and it's really important for everybody. So unless you have anything else, Jim, I just want to thank everybody for attending. I want to thank you and MAPEI again. These are the kind of webinars that are really beneficial to our industry, whether it's a designer, architect, a contractor, or even just someone working at a distributor or manufacturer. You know, knowing how to look at these manuals, how to read them, how to find the information and what it means, that will help everybody. So
I agree.
thank you very much.
It's a really, really important tool that you can use to your advantage. And I say that, you know, there's protection for the tile contractors, there's protection for the design professional if used correctly. So, you know, that's the intention of it, is to get the best installation you can get out of it by referencing these things properly. And as I said, the current year, you know, keep up with your reference standards. It's important.
Yes. And one last thing that you said that everybody needs to really hear one more time. The least expensive wall and floor covering can be tile and stone, and the most expensive can be tile and stone. And it comes down to two things: the material you use to install it and the installer you use. One thing is, I want to remind everybody, qualified labor fits right in with that installation product. You can have the best products in the world, and if it's installed incorrectly, you have problems. But using the best materials and the right materials and a qualified installer, you're going to have an unbelievable job. It's going to be fantastic. You'll be happy. So
Great refresh, Jim. I appreciate that, because I strongly believe that as well. No doubt in
I
my
know
mind.
you do. I know you do. I know MAPEI does all the way. We have a lot of support from the industry for qualified labor, and it's just growing. So
Yes, it is.
thank you, Jim. It means a
Thank
lot
you.
that you were here. I appreciate it. And everybody that's still here, which it looks like everybody's still here, thank you. Great information. Make sure if you didn't see Jim's email address, to send him your AIA number to get your CEU. You can also send it to me. You all received an email from me inviting you to this. So it's jim@tile-assn.com. Send me your information. We'll make sure you get your CEU. And please look forward to our next webinar, which I believe is on the 16th of this month, March 16th, Tuesday. Thanks, everyone. Talk to you soon.
Thank you.